Many radio operators use the term resonance and impedance matching interchangeably, but they describe two different electrical conditions. Confusing them can lead to misleading SWR readings, inefficient power transfer, and even damaged equipment. Here is the breakdown of why they are different and why both matter for your station. Resonance occurs when a circuit's inductive reactance and capacitive reactance cancel each other out. At this specific frequency, the antenna or circuit becomes purely resistive. Every antenna has physical dimensions that naturally resonate at a specific frequency, like a guitar string. When resonant, the antenna no longer pushes back energy into the circuit as reactance. The impedance is simplified to just the resistance. A resonant antenna does not automatically mean a 1:1 SWR. A resonant antenna might have a resistance of 15 ohms or 300 ohms. While it is resonant, it still won't match your 50 ohms radio. Impedance matching is the process of making the load, that is antenna plus feed line, look exactly like the source, your radio. Most modern ham radios are designed for a standard 50 load impedance. The goal is to maximize power transfer and minimize reflections. This is where antenna tuners' balance or matching stubs come in. They transform whatever antenna's impedance is into 50 ohms. You can match a non-resonant piece of wet string to 50 ohm using a tuner. The radio will be happy because of low SWR, but the string won't radiate efficiently because it is in resonance. Here is a comparison at a glance. Inductive and capacitive reactances cancel each other at resonance, while for impedance matching, load impedance and source impedance are matched, usually both are 50 ohms. At resonance, phase angle is 0 degrees. For impedance matching, SWR is 1:1. Main benefit of resonance is efficient radiation or absorption of signals for a reception. Impedance matching protects the final transistors. Resonance can be changed by change in physical length or size of the antenna. Impedance matching can be done using a tuner, balun, or transformer. Now, why is the confusion? The confusion exists because at the sweet spot they happen at the same time. If you build a perfect half-wave dipole in free space, it resonates at a length where its resistance is roughly 72 ohms. If you mount it near the ground, the resistance often drops closer to 50 ohms. In this specific case, the antenna is both resonant, reactance is 0, and matched, impedance is 50 ohms. Here are a few fuller scenarios. 1. Resonant but mismatched. A full-wave loop antenna is resonant, but its impedance is about 100 to 120 ohms. Your SWR meter will show around 2:1 SWR even though the antenna is perfectly tuned to the frequency. 2. Matched but non-resonant. Using a wide range tuner on an N-fed invisible wire, that is an N-fed thin wire stealth antenna, the tuner makes the radio see 50 ohms impedance. So the SWR is 1:1. But the wire itself is reacting wildly, often losing power as heat in the tuner or coax. To summarize, resonance is about antenna's relationship with the frequency. Impedance matching is about the antenna's relationship with the radio. For the best performance, you want to cut your antenna to be as resonant as possible for your target band and then use matching techniques to satisfy your radio's 50 ohms requirement.